So I thought I'd also record a video about how to do this problem. So multiplicity, not sure if you understand multiplicity 2 means it bounces at the 0. So let's make a little graph here. Didn't need to do the graph. See my work down below, but maybe doing the graph will help you. So I see at +1 there's a 0. I see at 0, I'm going to go 0 here at 0, there's a 0 here at 1, and a 0 here at -1. And it tells me that it goes through this point 548. So let's see, there's 1, 2, 3, 4, 5, and I'll fake the 48 right up here. Okay, so I know that this is degree 4. So it tells me the ending behavior has to look like this, right? It has to head up as x goes out into positive infinity, and it goes out to negative infinity. I mean, it could be open down too, like it would have to act like a negative x to the fourth, but I don't see that happen here with that point. So we won't go there. We won't worry about that. You might see that on the quiz on week 4. So pay attention to the behavior. And then, so what this graph's going to look like, let's see, where's the multiplicities? The multiplicity 2 at x equals 1. So that tells me this graph has got to look like this. It's going to come down like this. It's going to bounce off that point there. Then it's going to turn around and head through that point, and then it's going to head up like that. And this kind of confirms, because this is multiplicity 1 here and multiplicity 1 there. I mean, it just passes through the graph. And granted, this is a pretty rough graph, pretty lousy graph. But then I can kind of see, well, let's see, I know that y equals some stretch factor times x plus 1. So that's where, remember, if x equals -1, to set that equal to 0 to get the factors, we're going to add the 1 to both sides to make it x plus 1. And if it's just x, if it's x equals 0, well, that's just x. And then the last one is going to be x equals 1. That'll have to be x minus 1. And then, of course, that bounces. That adds multiplicity 2, so we're going to put an exponent there. And then what we're going to do is, you can see in my work, but I'll finish setting it up here. So I'm going to replace, it goes through that, this graph goes to this point 548. So I'm just going to do that setup. 48 is y. I don't know what a is, but then we do 5 plus 1 times 5 times 5 minus 1 squared. And you can see how I solved that for a. I think I got 1/10, and I just substitute that in. So this is what the multiplicity means, though, that it bounces off the graph. If it's multiplicity 3, you can look at some of those later ones in section 3. It's going to go through and wiggle through it acts like x cubed, only it's just been shifted over. So that would be, if it was a triple root, we'd have to have, if this is a triple root at 1, I would write x minus 1 cubed, and then whatever else, because it's triple root. Okay? I hope that helps.